Started. Okay, perfect. Hi everyone, this is Amit. I'm a technical marketing engineer with FlexPod with NetApp. It's a converged infrastructure offering. Hope you guys had lunch, so I promise I won't put you to sleep, so let's get started. So throughout the conference, we have been hearing about cloud native applications and how do I support them. And there are multiple topics. Like I grabbed a small screenshot from the keynote that we had on day one. As you can see, there are multiple, I would say, projects involved in the open infrastructure. And that is something important if you want to power a cloud native application. So like, okay, you need to power a cloud native applications. And with the current paradigm of DevOps mindset, where there is self-provisioning and self-service portals, that there is no longer the ticketing system. You don't want to be stuck by tickets before your infrastructure gets provisioned. So how do you build the underlying infrastructure to achieve that? So there are a couple of important aspects that we should consider when building such infrastructure that can give you a cloud-like service model. So like the first of all, like the first tenant, core tenant is having a software-defined infrastructure. And trust me, I'm not talking about the buzzword software-defined. When I mean software-defined, like I mean something which can talk APIs or which can basically has integrations with different tools, like especially open ecosystem tools like Puppets, Ansibles, Chefs, and the other commonly orchestration tools that we use. And when you're designing such an infrastructure, it's important to consider the design of the whole infrastructure as well. Like you have your compute, network, and storage. Can you extend the compute without modifying the storage? If you need more storage, can you add them independently or things of that nature? And as we can see, there are multiple layers to the stack as well. So for example, you have your base operating system, then you have your hypervisor, etc. But you have to be cognizant of the fact that you have to manage them by yourselves if you are going to do it. So like for example, there were consider security vulnerabilities. So there were about in 2017 year, so I guess there were about 6,500 security vulnerabilities, and out of them, almost 250 had to be done on the same day. So do you have to consider if you have the infrastructure, if you have the talent and the skill to manage that and do it by yourself? And the last thing is, once you have this infrastructure, can you, it's important to verify and test and validate. I mean, all the three mean the same thing, but I noted it down just to prove that it's very important. So once you have your infrastructure ready, you have to run certain workloads, like spin up around 1,000 VMs or 2,000 VMs on the workload, have a burst rate of about 25 to 30 VMs per second, and see does the infrastructure operate. And does it actually meet the SLAs that the cloud demands? So like these are multiple things that you want to consider, and like we discussed in our keynotes, it's a very big topic that it's a very big, there are multiple components involved in the stack. And the screenshot on the right hand side just shows you a few of them that you can use. So to achieve that, sorry. Yeah, so to achieve that, Red Hat, Cisco, and NetApp have come together to develop a solution. It's Red Hat OpenStack platform on FlexPod SolidFire. I'll get into details more, but just to give you an overview of the program, it's about the subject matter experts from the industry. So for example, the networking and the servers, we use Cisco UCS servers and Cisco Nexus switches. So we have industry experts from all of these, and for storage, we use NetApp SolidFire storage. So the industry experts from all of the three companies get together and sit down and then have a validated design that you can actually deploy. So I'll have more information about the solution in the few further slides, but this program hasn't been something new. It has been there around 6 years now, and it has about almost 700 plus customers and has over 10 billion revenue till date. So it's not something new, and it's important to understand that it's truly the reference architecture is completely validated and tested by in the lab. So just to get started, why NetApp for OpenStack? So this is one of the slides that I have, which translates the NetApp storage for OpenStack, and it's basically all the. I'm not going to go into detail. I'll just cover on a high-level view. But as you can see, ONTAP is our multi-protocol storage operating system. So basically, you can have file storage, block storage over iSCSI or Fiber Channel protocol, and it has integrations with the different drivers in OpenStack as well. So these drivers are natively out of the box, and basically they have been tested and they are upstream, and they are also included and certified in the Red Hat's OpenStack distribution. This. Yeah, I think it came back, yeah. So, and the other component is solid. So basically, the solid fire storage, you can power your Nova VMs. You can have persistent storage for the VMs using solid fire storage array. And as well as for the other components like Swift, which is an object storage, you can carve out LUNs from a storage array and attach it to the compute nodes. Having said that, that was a brief overview of the NetApp portfolio for OpenStack. Let's get into why do we need a converged infrastructure. Like I mentioned, converged infrastructure is nothing but compute, network, and storage, which is bundled together in a pre-validated form. So one important thing to note that each component in the FlexPod is individually scalable. So you can add more storage without adding more compute or vice versa. And one of the important aspects of the infrastructure is API driven. So all of the components, whether it is Cisco's servers or Cisco switches or even NetApp storage, everything can be talked to using API. So it serves the DevOps model where you can provision on demand. So having said that, let me introduce the core platform for this solution, which is FlexPod SolidFire. So FlexPod SolidFire consists of Cisco switches. All variants of Cisco 9K switches are supported, and these are bundled together in a VPC in a port channel manner, and you have VPC configured with them. So, and it supports multi-chassis link aggregation. So basically, all of your you have a redundant HA in your for your network. Both the switches act as one switch for your network traffic. The second component is the storage array itself. So this is SolidFire 9608 storage array. So this, to tell you how software defined the solution is, the operating system for the SolidFire is Element OS, and it's basically running on Cisco servers. So as you can imagine, the software for the storage is decoupled from the hardware. So, and right in this solution, it is running on the Cisco UCS 220 nodes. It's a 10 gigabytes iSCSI solution, and with SolidFire cluster, you need 4 nodes to form a cluster, and then you can add 1 node at a time to scale up without having like the traditional HA manner where you needed 2 nodes to scale your storage. And these are some numbers about the 4-node cluster. Like it has 300K IOPS and 30 terabytes effective. This is an all-flash array which supports all the deduplication, compression, to give you all the storage efficiencies that you need. And you can add 1 storage node at a time. So basically, it would give you, like if you divide it by 4, it's like 75,000 IOPS and 7.5 terabytes storage. So you can add 1 node at a time, which is incremental. And the last part is Cisco UCS B-series servers. So these connect to any 6300 or 6200 fabric interconnects. One cool thing about the Cisco UCS servers is the service profile aspect of it, where the physical nature of the where the physical aspect of the servers, like the MAC address, WWPN, etc., those attributes are abstracted away from the actual servers. So to give you more detail into the solution, so this solution uses Red Hat OpenStack Platform 10. Some people might be considering why OpenStack Platform 10, but Red Hat has a release. So Red Hat supports has a release cycle where they have a long-term release and one-year releases. Red Hat OpenStack Platform 10 has been the most stable version of OpenStack, with almost 5 years of support. So from a support perspective, it has almost 3 plus 2 years of support, and basically it is enterprise hardened code where Red Hat validates each portion of where Red Hat validates the actual OpenStack drivers and even certifies different vendors with it. And the good thing about having a distribution of Red Hat's distribution of OpenStack is the security patches and the support that you get with it. So if there are any updates to the drivers, or if there are any operating system updates as well, then Red Hat has a process where it automatically patches all the security vulnerabilities and patches and rolls it into the distribution. So you can concentrate on your business rather than worrying about the infrastructure. Some of the design decisions for the solution, I'll be mostly concentrating on the storage aspect of it. So like I mentioned, you can have service profiles for the UCS server. So your your operating system is no longer tied with the actual blade, but since you can SAN boot it off iSCSI nodes, you can basically switch the individual servers. So basically, during a maintenance, if your controller nodes needs to be shut down, you can turn off the blade and point it to a different service profile, but you have your operating system on a LUN. So basically, you have a non-disruptive control plane as well. And as far as the other storage solutions for OpenStack, so we used NetApp SolidFire Cinder driver, which basically provides Cinder volumes. And it's an iSCSI solution, so it provides them through the iSCSI protocol for the LUNs that are created on the SolidFire array. One additional thing is Swift. Swift is an object storage, as many of you know. So the individual LUNs for Swift are mounted on the controller nodes, and then Swift lays out an object store on top of it. So basically, you have your object storage also satisfied through the storage system. And Swift provides glance, backend for glance as well. It's important that you don't have your images contained on the same controller node, because if one of your controller node goes down, then you can't access the images. So it's important to have a highly available image store. You can either have an NFS solution for it, or you can have an object store which is highly available. The next portions were the network design. So all the network traffic is segregated using VLANs. So the infrastructure traffic for OpenStack, which includes the PXE or iSCSI traffic or the tenant traffic, it's all isolated using VLANs. And as far as the tenant networking goes, we have validated the ML2 VLAN driver, and we used the Cisco UCS manager and Cisco UCS manager and Cisco Nexus Neutron driver. So basically, what these drivers do is they dynamically manage the state of VLANs on when a new tenant creates it. So for example, when a new tenant creates a new network, it dynamically tags those VLANs on the switches and the on the UCS fabric interconnects as well. So you don't have to manually go and provision VLANs on your infrastructure. So everything you operate is through OpenStack control plane, and there is very few dependency on the infrastructure. To get into more specifics, the NetApp SolidFire Cinder driver, the cool thing about it is it requires literally zero configuration on the storage array. So I mean, like any other Cinder driver, it just requires a few lines of configuration in the cinder.conf. I highlighted the cinder.conf in the image there, and basically that's all you need. So when you create a volume using Cinder, it automatically creates a corresponding tenant on the storage array and maps the OpenStack tenant to the storage tenant. You can have your QoS features like MinOps, MyOps, MaxIOps, and even Burst IOPS. So these map directly to the storage array. And there are more triaging features as well, like the UUIDs of Cinder map to the volume UUIDs on the storage. So there is one-to-one correspondence between OpenStack Cinder and the underlying storage array. So, and you require literally zero configuration with the infrastructure. And like I mentioned, the Cisco Neutron drivers, basically these are the Cisco Manager and the Cisco Nexus switches. So they manage the life cycle of VLAN. So even for the provider networks and for the tenant networks, as you add more VLANs, these are dynamically managed using the Neutron drivers. And as a part of the solution, since we have designed the whole infrastructure by ourselves, we currently know each individual components of the solution. So it's easier to write heat orchestration templates which deploy the over cloud for you. So as a part of this solution, we have also released a bunch of heat orchestration templates for deploying the solution. And these basically cover the entire configuration. Like once you have your undercloud deployed, they basically go and configure the NICs on your devices, on the controller nodes and the compute nodes, and then configure the corresponding drivers, so whether it be Cinder or Neutron. And if you need to do any additional configuration, it also does that. And for this solution, we used like all the three controller nodes are operating in an HA manner. That's pretty standard if you're deploying an enterprise version of OpenStack. And once you have HA, so you have HA both at a software layer and a hardware layer. So from a hardware perspective, the design that we did from an HA perspective, the design that we did is completely highly available in terms of switches, in terms of the networks, as well as storage, going all the way till the compute. And from a software perspective, since we are running the services on all the three controller nodes, it's running in an HA fashion. So last couple of slides, and one good thing about the FlexPod is the cooperative support model. So this solution has been co-jointly developed by experts from Red Hat, NetApp, and Cisco. So basically, if you have any, once you deploy the solution, and if there is any support case, you can contact any of the vendors, and then the support call gets routed dynamically. So you don't have to triage the issue to the individual components, or whether it is a networking issue, whether it is a storage issue. You can directly contact any of the vendors, and the support will be provided. So, and these three companies also run a support lab. So basically, all co-jointly. So any issues or any triages will be resolved in the lab co-jointly. So this is the collateral for the solution. I think the images. So I guess there's an overlapping image on one of the slides, but NetApp.io is our NetApp.io is the place where NetApp has all the NetApp puts all the open ecosystem collateral there, so you can find all the information related to configuration management, containers, or OpenStack, and that's what that logo is referring to. And specifically for this solution, there are two collaterals, a design guide and the deployment guide. So I covered the design portion very quickly in this session, but you will find all the design decisions and why have we taken that in detail in the design guide, the link that you see. And as far as the deployment guide is concerned, it follows a step-by-step procedure of deploying the whole infrastructure from beginning till you deploy OpenStack, and it also performs certain validation checks. So all that information can be found in the deployment guide. And also, I would like to point out to netapp.io/Slack. So this is where you can if you have any technical difficulties, you can join the Slack channel and ask questions. And trust me, marketing doesn't know about it, so it will be all engineers will be responding. With that, I think we are almost at the time, so I think that's it.